Okay, you should see a message saying that this is now being recorded. If you have any concerns about being in the recording, you do not have to show your video or be involved in the chat sessions. You could feel free to just participate. And so let me bring up the presentation and we'll get started here. I know that, actually, by the way, it's so about 5:07 p.m. Eastern Daylight Time. We're located in the Toronto area. It looks like there's people from all across Canada as well as from different parts of the world. So thank you for joining us. It feels like truly a multinational event. And thank you for taking time to come out to this great event because we have a great speaker and a great topic. So that's a hard combination to miss out on. So I'm glad you could join us for this. And so I'm going to get started a little bit here. So let me get rid of this on the corner here, and I'm going to start this up in full screen. And once I finish talking and giving you a little bit of an overview, I will pass it to our speaker, Aidan Ermey. And we're fortunate that Aidan Ermey is also one of the organizers. So I'm just going to make this full screen here. Okay. So for anyone who's just joining us right now, we're getting started. The session is being recorded, and the topic is Infrastructure as Code, IaC using Terraform. Both extremely important topics and very popular. I work in the Azure cloud space as well, and I could tell you that this is a fantastic topic to learn about. And I'll let Aidan do more of an introduction on his role, who he is, and the topic itself. But let me just start off talking about the Azure Group, also known as TAG. We are based out of Toronto, Ontario, Canada, and we are a meetup that used to meet in real life, in person, and have a chance to socialize and network. But now we are all working remotely and meeting up remotely, including having these presentations remotely. And so let me introduce, besides myself, Arlo Noguera. The two main organizers of this meetup is Ezekiel Calabria from vNextIQ and Aidan Ermey from Microsoft. And I'm just going to go to the next slide and tell you a little bit about the sponsors that we have here. So a big thank you to our sponsors, Microsoft Canada, as well as vNextIQ for their support and generosity to make this event happen, in various support and support, as well as providing infrastructure as well as resources to make this event happen. So thank you very much to both companies. So I know these are difficult times for everyone, and so we always want to stress, staying home, staying safe, staying positive. And I know things are starting to loosen up, not only in Canada, but around the world as well. So it's a time to still be safe and be careful and stay healthy. And I hope you and your family are doing well during these very difficult times for many people. So what I'd like to do is talk a little bit about some of the resources that are available through Microsoft. There are a huge amount of resources available for free that you could use to learn new skills. If you're not working right now, or you're looking to make a career change, there are extremely valuable and high quality resources available for free. I want to stress that free part is an important part, available from Microsoft. And you'll find that the one I'm pointing to right now on the slide deck is learn.microsoft.com. They have lots of great content, not just on Azure, but in other areas. They including have information that allows you to take learning paths that will allow you to become certified in different areas, including Azure, which is a great area with a lot of demand that I work in and Aidan Ermey works in. And there is a lot of demand for that. So if you're looking for a career change, or you're looking to have new skills for the current work that you do in the cloud, this is a great place to start. And you'll find that there's just a huge amount of high quality resources for free. So I just mentioned about the Azure Learning Path and Introduction to Azure. So that's actually one of the paths available through the online learning from Microsoft that I just showed you in the previous slide. So definitely check it out if you want to learn more about Azure. It's definitely a great area to learn. If you're finding that you want to learn Azure, but you do not have access to any Azure resources or subscriptions through your company or any other option like that, please be aware that you can actually get access to an Azure trial subscription where you get $200 US or $260 Canadian in credit, and that allows you to access these resources in Azure with a few restrictions or your learning path. So if you want to take some certification on Azure and you want to have access to Azure resources and Azure Cloud, you'll find that by signing up for this offer, you'll find that $260 Canadian or $200 US goes a very, very long way to get you through that learning process for certifications or just general Azure skills. And some of these services are free for up to 12 months as well. So I would definitely check it out. You can just go to azure.com and you'll find that you'll be able to see the different services that are available to you. And I believe you could actually do that without a credit card as well for the initial credits that you receive to learn and work with Azure. There's also lots of great content on a non-Microsoft website called edX. And if you're not familiar with edX, it is something that you'd want to explore not only for Azure, but the other clouds such as AWS and Google Cloud Platform, GCP, and also lots of other topics that have nothing to do with the cloud or even technology. edX is a great place to go to continue your learning online, and that's a very good option to consider these days because the traditional process of sitting in a classroom and learning may not come back in that form for quite a while, or at least not in form that we may recognize or find accessible going forward. So definitely check out edX.com. And again, the Azure Group, this meetup that you joined, is based out of Toronto. We are right now close to 1,500 members, and thank you for joining. And if you're new to the user group, I hope you've joined the group as well. And after this presentation and having a chance to experience it, hopefully you'll tell your friends and colleagues, and they'll come out as well and join the next session that we'll have in the Azure Group meetup. And also, if you want to follow this user group on LinkedIn, you could do that on, if you go to theazuregroup.org/LinkedIn, it will take you there. And you can also do a search within LinkedIn itself to find the Azure Group. And that is the end of this introduction. And I'm now going to pass it over to our main speaker. And I'm going to have Aidan Urmi introduce himself and the topic. One thing I should mention is that even though the time slot is scheduled from 5 to 7 p.m. Eastern Daylight Time for 2 hours, the presentation will take about 1 hour approximately, with a Q&A at the end of that. And feel free to ask questions. If you want to come off mute, if you feel that you have an important question that the user group will benefit from, that you would like to share with everyone, Aidan is very open to being asked questions while he's presenting. If the question is maybe too long or complex or not suitable to answer at that time, or there's actually a set of slides coming up later, Aidan will let you know that he may take that question later, and he'll be available for as long up to 7 o'clock, even if you have additional questions you'd like to ask on Terraform. And so don't feel reluctant to send questions through the chat window, or just by coming off mute and asking Aidan questions directly, which might be the most effective way, and then it'll give you a chance to interact with Aidan directly. I do ask that if you're not asking questions, that you go on mute, just to avoid any background noise, which will be a disruption to others and our speaker, who will appreciate that as well. So Aidan, I can see you there. I like your background. That's great. So I'm going to pass it to you now, and I'm going to go on mute and enjoy this presentation as well. And off to you.
Okay, perfect. Thanks. Everyone can hear me okay? Everyone can see the screen? The presentation is up, yes?
I see you, Aidan, but I don't see the presentation.
Okay. 1 minute. Let me try resharing that. I'll share my screen instead and see if that is any better for everyone.
That is working. I can see you now.
Okay,
I can see the PowerPoint deck. Okay, so I will pass this to you, and I'm just going to go on mute here, Aidan. And like I said, feel free to interact with the participants of this meetup, as well as for anyone on this call who just joined. Feel free to come off mute if you have questions that are relevant for that particular section that Aidan is speaking about, but also feel free to ask them at the end. Aidan will be available from whether you need 5 minutes or all the way up to the full 7 o'clock Eastern Daylight Time. He's here to ask questions of, and I would say definitely take advantage of that. It's very hard to find someone of this knowledge and expertise, not only on Azure, but also on infrastructure as code and Terraform. I would say definitely take advantage of the Q&A session at the end, especially if you have more longer, more complex questions. So that's all I want to say. Aidan, I'm going to pass it to you.
Okay, thanks, Arlen. And I do see a comment in the chat that maybe the volume is a bit low, so call that out. If I'll try to speak a bit louder, hopefully it's clear for everyone. If it's not, then yep, go ahead.
It does sound loud and clear to me, Aidan. So I don't see any issue there, and your PowerPoint is nice and clear and visible. I don't see any disruption. Your background image on you, though, it's a little hazy, just because I guess there's a lot going on in the background around you.
Yeah. Well, if it disrupts the video or the sending of the screen or something, I can disable the video. No, sometimes it interrupts. So
no, it doesn't. I just thought I mentioned that. That's the only thing that's just a little fuzzy, but your voice is loud and clear, and I can clearly see your intro slide on the PowerPoint that you're sharing out right now.
Okay, perfect. And yeah, it doesn't matter, but the background should focus on the slide anyways. Okay, very good.
Sure.
Yep. So let's begin. I just want to kind of preface everything to level set with everybody on the call. Thank you for taking the time to join us today, this evening. We're going to talk about, obviously, Terraform. We're going to talk about infrastructure as code, but to kind of level set for expectations, it's not going to be like extremely deep, super advanced. We're going to start with some basic constructs, foundational knowledge and understanding of Terraform and infrastructure as code. And why we're starting with that in this presentation is because other presentations that we've done in this user group or other user groups in the past around infrastructure as code in general, a lot of people have asked about Terraform specifically, wanting to know, oh, I want to learn Terraform. Where do I start? How do I begin? What do I need to know? How does it compare to ARM from an Azure perspective and so forth? So that's kind of where we're going to start today. With this presentation, but definitely if there is interest in more intermediate, more advanced level topics around that, real world examples that I've done, we can definitely schedule like a follow-up, another session around this for everyone to join in on. Okay, so I see some comments in the chat that everything should be clear, loud and clear. Excuse me. If it isn't, I'll try to keep an eye on the chat on my second system on my left. But if I miss any questions or anything, Arlen is going to call that out for me. Okay. Also, I'm going to just call out, we have a large number of people that have registered for this. We have special guests, so to speak. We have people from not only from Microsoft, like myself, but other colleagues that I work with, but also we have some people from HashiCorp here today, which is really special. So as I'm presenting, if there's questions that I'm not seeing, they might jump in to answer those, or they might jump in part of the presentation, and that's totally fine. Perfect. Okay. So here's our agenda for today, this evening, this afternoon, this morning, depending on where you're calling in from. We're going to first talk about the benefits of infrastructure.
Aidan,
yep.
Sorry to interrupt. Would you tell us a little bit more about who you are, what you do, and how you came about to all this, including Terraform, the path to that got you here?
Yeah, that's a bit at the end, but sure. So just to preface then, my name is Aidan Ermy. I work for Microsoft as a cloud solution architect, specializing in Azure infrastructure. I have a lot of experience prior to coming to Microsoft, working with and for different Microsoft partners in different industry verticals around things like ARM templating and specifically in Terraform. A lot of my experience I'm going to draw from my real world experience that I'm going to share today on deploying global scale environments across multiple Azure regions all over the world using Terraform. So the whole DevOps mentality, infrastructure as code, pipeline processes, things like that. And really, back in the day when I first started with ARM and I first started with Terraform, it's a little overwhelming, right? Because there's so many things out there. But it's really about starting small in kind of little building blocks and kind of add pieces along that. Does that help, Arlen?
That was great, Aidan. I didn't want to take any away in your special journey and path to Terraform, but for people that just joined, I missed my intro. I wanted to give a little intro of who you were and the context for the presentation. Thank you.
Sure. Yep. No problem. And my contact information will be at the end as well for people to reach out and connect. Excellent. So what we're going to talk about today, we're going to talk about benefits of infrastructure as code, just to kind of level set. I'm sure a lot of people on the call are already familiar with infrastructure as code, but some might not be, or in some aspects of that. So we're going to touch on that briefly to kind of level set there. Then we're going to talk about what Terraform is and what it is not, why people love using Terraform, kind of digging into some of the value propositions around Terraform itself. Then we're going to look into some of the basics of the language. So we're going to actually go through and break this down into different pieces and components like we see listed here. And we're actually going to, after we review the elements around this, we're actually going to go through a live coding sample in building out a very simple yet a little simple environment, just a storage account, of course. But we're going to build these constructs as we've learned them to kind of piece that together and see it in action and kind of really cement what we're learning. After that, we're going to compare ARM from an Azure perspective, the Azure Resource Manager templating language compared to Terraform, because again, there's a lot of interest around both of those constructs that people have asked repeatedly in the past. So we're going to kind of show the differences between the two to help understand the pros and cons or on both sides, and when you want to use what and what the value is in that constant. We're also going to provide some best practices in leveraging Terraform as well. Things you want to keep in mind so that you start off on the right foot, right? So you start off in the right way from day one, and you're not developing maybe a habit or a methodology that you'll have to kind of revert back and change. And then lastly, we're going to provide some resources for learning because the internet is full of information to learn. So we're going to provide some curated information that we found most effective in learning Terraform from the ground up, just starting off, understanding the progression from one person just doing it to an entire team or enterprise doing it, as well as certification, as there's been a lot of interest with the Terraform certification that's been recently released. Let's start.
One point. Yep. Sorry, one point I wanted to mention for people who are just joining, this session is being recorded, so you can actually view it later, but also this PowerPoint deck that Aidan is using will also be made available through the Meetup page. So if you're wondering about trying to take some notes or screenshots, please be aware that the recording, as well as this PowerPoint deck, will be available through the Meetup page later this week. Thank you.
Yep, no problem. And good point, Arlen. So I have some links in the deck. Of course, obviously you can't click on the link when you're viewing it here, but yeah, those will be made available to everyone afterwards, so you'll have access to those resources. So let's kind of start with a level set of what the benefits of infrastructure as code is. Right? Everyone talks about it. Oh, everyone needs to do this. It's the whole DevOps process, and everyone wants to do DevOps. But what benefit do we get from shifting into this infrastructure as code construct? Right? So the first bullet here is talking about reproducible environments. So as an example, I'm going to relate a personal experience that I had a few years back, where I was actually deploying the Microsoft System Center Operations Manager, or SCOM, monitoring environment in an enterprise environment. So I'm going through the installation, and my colleague beside me, as we're going through the UI, the wizard, next install, right? Before we get to the install point, we're partway through, but we haven't clicked install yet, and he paused me for a minute. He's like, "Wait a minute, go back a couple screens," and he was able to pick up on that we had configured it incorrectly to deploy, say, to the wrong drive, for example. And that's a good example where, a UI interface, a human interface that we are clicking through, especially if we do a lot of that in our day-to-day work or even in our personal lives, we might just tend to be like next finish, next install. And we can easily misconfigure or not align an environment to what we actually need. And then we need to tear it down and redo it or something to that effect. With infrastructure as code, when we're building our infrastructure templates as code itself, it makes it more reproducible in a consistent way, right? So you're able to say, this is what I want deployed. This is how I want it configured, what properties I want it to have, what size, what shape, what area I want it to be. And then using things like variables, of course, we make that reproducible or repeatable in, say, a DevOps pipeline, or even just manual execution. But we're ensuring that the deployment of that infrastructure is consistently the same, regardless of where it's going, because the template controls that. So that's kind of a key of value to infrastructure as code. Even though we can, in the traditional sense, we used to have like run books or deploy books or build books for environments. Once that's been written, well, then the environment is live, right? And then things change and things are tweaked and modified. That's where things like trackability or traceability with things like GitHub or other source control environments come in. The code itself that we are building, that template we are building, serves as that documentation. So as things that are adjusted in the environment, depending on what we need to modify, let's say we deploy a server, we hand it off to the application team or whoever's going to use it. They come back, we need some modifications, we make those changes so they can continue to do their job and do their work. But those changes, are those captured anywhere? In a traditional process, probably not. Maybe a little bit, maybe in a ticket, service request or something like that. But when we go to redeploy that environment, that knowledge is either stuck in someone's head, maybe it's on a scrap of paper, or it's on a little OneNote or something somewhere. And when you redeploy the environment, if it's the next person down the line to do so, they're not going to know that these other configurations, these other tweaks and modifications are required to make the environment usable for the purpose that it's being built. By using things like source control with templated infrastructure, it allows us to be able to see who changed what in the code and why they changed it. We can have like a gated process available so that it's reviewed before it's deployed in, say, production versus dev or test. So we also can leverage these templates to put into our CI/CD, our deployment pipelines, when we get into the whole DevOps process, right? It's not necessarily that we have to do that, but even having a template and a repository of templates, and maybe you're manually triggering it, at least you're getting into the habit of being able to track, here's our baseline infrastructure, here's the baseline properties that have been put in place. And as that needs to evolve, as that needs to adjust for what's really happening in the real world, that's also being tracked as part of that version history for that template file. Workflows we'll kind of talk about, and providers will talk about more in a Terraform specific context, but basically this is what allows Terraform as an infrastructure as code tool to target against specific environments and certain clouds and so forth, and how it operates for applying configurations or destroying environments and things like that. What it's not is, infrastructure as code is not used to apply the same configuration, especially across different clouds. We're going to touch on this in a little bit more in the next slide. So we'll jump over to what Terraform is. So those that might not be aware, Terraform is a templating language that was created by HashiCorp, called HashiCorp Configuration Language, or HCL for short. It's written in Golang. And Terraform is a tool that allows us to templatize and codify the orchestration, the delivery, the provisioning of different environments and infrastructure. So we see examples here like different clouds, even on-prem like VMware, other systems like Cisco or New Relic. It uses state files to manage what's happening live in the real world, which we'll touch on a little bit more depth in a little bit as we break down the language. But Terraform is not used for configuration. Right? It is an infrastructure as code language. There's other tool sets like PowerShell DSC, Chef, Puppet, Ansible that can be used for configuration. And some of the resources that we have at the end of the presentation, there's a really good article that explains why one organization chose Terraform over something like, say, Ansible or Puppet to use as its infrastructure as code construct or technology. There's some companies that I've worked with, some customers I've worked with, where they say, oh, well, I'm going to use Ansible to deploy my infrastructure, even though it doesn't do everything I need it to do. So as long as it can get me 80% of the way there, I can just script the rest. Well, that's true, but it's kind of like using a fork, right? It's half spoon, half fork, right? It works, but it's more effective to use a tool, specifically a fork or specifically a spoon, that's been purposely designed for that use. And that's why there's maybe a bit of debate of this, of course, but it's more effective to use a tool designed specifically around infrastructure as code and leave other tools that specialize in configuration as code separate. Why do people love to use Terraform? Well, first and foremost, as you'll see in our walkthrough and in our demo, Terraform is very clean, very easy to read, easy to write, so it's more comfortable to work in. It's a declarative configuration. So as an example, if we are deploying an environment and using, say, PowerShell script or some type of scripting, in that script, yes, we can deploy our infrastructure, but in the script, we have to tell it, I want you to do X, Y, and Z in this specific order. You're telling the script what to do and how to do it. With infrastructure as code and Terraform, you tell it, this is the resource that I want, and this is how I want it configured. These are the properties I want it to have. And you're letting the engine and the platform that you're targeting to figure out all the order of operations and everything that needs to happen to make that desired configuration, that desired state, true. You don't have to worry about telling it what order to execute. It will figure that out and manage that for you. Now, we already talked a little bit about version control, but if we think about it from the aspect of a developer, right, an application developer, they have version control, different versions of their applications, different feature versions, and so forth. But now we're trying to take that construct into infrastructure so that we can, again, have our template saying, this is how it was day one, but then a new requirement came in. So yes, we may have made the change in the environment or allowed someone to make the change in the environment, or better yet, taking that new requirement, adding it into the existing template. So now we have a new version of that template and that code, and redeploying that in the environment so that the existing environment is either updated in place or redeployed in a new instance, and then the old instance is removed. The other point is about having implicit dependencies. So in some languages, you have to explicitly say this resource depends on this other resource. So resource B depends on resource A. But in Terraform, when you have a relation saying resource B is referencing something from resource A, it's implicit. It understands that, well, I need to finish creating resource A first in order to have this property or whatever resource B is referencing in order to create resource B. So it really simplifies that process versus having to explicitly list that for every single resource and forcing you to kind of manually create an order of operations. And finally, the last bullet here is the ecosystem. Why people love Terraform? Look at all the logos on this page. This is just a handful. I don't even know what percentage this is, but just a handful of different providers that are available through Terraform that you could use Terraform to code against. So we have all the major cloud providers at the bottom and some other niche area cloud providers as well. We have like hardware and infrastructure, like physical infrastructure. We have things like Chef, we have Active Directory, we have Azure Stack, we have things like Bitbucket and GitHub. We even have things like Kubernetes, Helm, and Docker. So even the microservices, the container and serverless space has providers available in Terraform that allows us to write Terraform templates against and be able to manage and control. Now notice in the bottom right corner, I have the Kubernetes symbol highlighted in green with the word new. This is because hot off the press, literally today, actually maybe it was yesterday, my bad, within the last few days, Terraform and HashiCorp has released the alpha version of their Kubernetes provider. And with this, it actually lets you manage your packages, your deployments, and all your Kubernetes resources through Terraform. That means you can control the entire life cycle of Kubernetes and its workloads using Terraform with this new provider. So that's just been recently announced. I believe it was the 26th. I believe it was yesterday. So we see there it's a very active ecosystem. Many providers are updating things, adding different things to make it even more and more robust. So I see a question in the chat. Is it true that the HCL written code in Terraform is compatible with multiple cloud platforms like Azure, AWS, and so forth? So excellent question. So how do I, well, when we get into the code examples, it might help clarify that. But yes, in a nutshell, what happens is when you learn Terraform, the syntax of working with Terraform, how the template files work, how state files work, and variables and so forth, all of that is the same. But the provider that you're targeting against for your deployment will change some of the code that you're developing. So it's not like you can write a generic Terraform template, say, to deploy a virtual machine, and it's genericized, and then you can target and say, okay, take this and deploy it against Azure and AWS and GCP and Oracle Cloud and Ali Cloud and so forth. It's not like that. You'll see when we get into the code examples on the constructs of the provider and how you're targeting resources specifically to that provider and the properties available. When we get through that, if there's any follow-up questions or if I haven't explained it clear enough, then please do bring up the question again. Thank you. So let's talk about the basics of Terraform. How does this work? We need a good foundation to start so we understand what we're going forward with. So firstly, in Terraform, these are the main commands and workflows that you're going to use. Yes, there's other commands available to use in Terraform, but these are the primary four that you're going to initially operate with. So first of all is init, right? Initialization. What's happening here? This is where Terraform is preparing the working directory that you're using. It checks for any like backend initialization, which we'll get into in a moment, what backends are. It checks for that configuration settings. It checks any module blocks that you have or that you're calling, any requirements from those. It checks what provider you're targeting against for your deployment and any plugins required to work with that provider. The next stage is plan. What happens with plan? Well, this is where Terraform is planning, obviously, to create your execution. Is determining, okay, what actions are required to achieve the desired state that you have specified in your Terraform configuration file. And there's an optional argument that can be put in the command line called -out, where you can take Terraform's assessment of your code when you do Terraform plan and put it out to a plan file so that you can execute that later, say in a CI/CD pipeline. Next in the general flow process, workflow process is apply. So we're taking what we've put in our template, and we are actually, this is like the deploy trigger, right? We're scanning what we have, and we are taking any variables that we're passing in either in the command line or through files, or things are extrapolated, and then we are triggering this deployment against that resource provider and against the environment that we're specifying. Now with the variables, like I said, you can pass them in through command line, but you can also have a separate file. So a good example, real world example in this is, let's say you have a bunch, your Terraform template to deploy your code for networking. Well, you can have a separate variable file so that it can be obviously parameterized and say, I'm going to have these variables because I'm deploying this to production, or these other separate variables because, or values for those variables for applying this to development or test. Same thing applies from, say, regions. So as an example, with some code that I wrote for deploying a global networking environment inside of Azure across many Azure geographies and regions, we had a separate Terraform variable file specific for each region. So this is the core networking for Canada Central. This is the core networking variables for Canada East. So then the template itself stays the same. Again, consistency with the resource being deployed, but then just the values are changing specific to where I'm deploying and what I'm deploying, say, in an environment. Lastly, in full circle, of course, is destroy. When you no longer need the environment, right? Maybe it's like a testing space, you're evaluating and testing your templates, for example. It's a dev space. You want to be able to remove any resources that you've deployed and managed through Terraform. So the deploy command will accept all the same arguments that the apply command does, with the exception of a plan file. So you can't pass a plan file into a destroy command. There's also a parameter or a command line property called auto approve. That will not prompt you to confirm you want to initiate that action. So be very careful, because as we'll see when we go through our demonstration and our live code, we're going to be prompted about what we're creating, and we're going to be prompted about what we're deleting. In a pipeline process, right, you don't necessarily want that, because that'll hold up the whole CI/CD process. But be very careful when you use that auto approve, because then that will not prompt for confirmation and just go ahead and destroy what you're telling it to destroy. So let's look at the basic resource creation construct here in Terraform. So we have three different pieces that we have highlighted here. Each of these are like resource blocks that describe one or more infrastructure object that you want to deploy, like a virtual machine, or in this example, a resource group in Azure. So the first piece is the resource type. So notice that this tells it what kind of resource object you wanted to deploy, but then also tied to what provider this is against, which tells Terraform which plugin that you need, that it needs to reference to create this resource. The second piece is the name block. And so this is specific to Terraform. This is not the name of the resource in the properties of that. This is used so that can reference back to this resource in your code for some other type of a dependency, as an example, which we'll see in our live demo. So it doesn't have to be the same, even though it's the same in this specific screenshot here, but it has to be the combination of the name and the resource type within your Terraform template itself has to be unique. So if you wanted to create multiple resource groups, you cannot have all of them be called from the name construct shared services RG. They have to be unique within that module. Lastly, we have the configuration. This is the properties, the details of what we're passing and what we want that resource type to have. So keep in mind that it's subjective to the type of resource. So in this case, we're deploying a resource group. So it has a name and location, and there's other properties that can go along with it. But the properties in this configuration aren't all going to be universally the same. The properties that are available to deploy a resource group is not the same, say, as deploying a database, right? They're not, some of them are going to be the same, like name and location, but there's a lot of other different properties. So this is what we're specifying and telling Terraform to tell Azure, in this case, that we want this resource group to have these properties. So this is what the file structure looks like in Terraform. And we can just take a look at it for just a couple of minutes here. We're actually going to go into each block of these pieces and dissect them and explain them in a little bit more depth. So I've broken it up into two screenshots just to make it a little bit more readable on a screen, else it'd be really, really small. So it starts on the left top to bottom, and then goes over to the right top to bottom. So we're going to dive into these different pieces. So the first piece is backends. This is where Terraform determines how and where it's going to manage its state file. And we're going to touch on state in the very next slide. But this is where it controls and records what we're doing and the values and the outputs of that deployment are going to be. Now notice the first piece in this Terraform block, though, we have required version. And I'm going to specifically call this out because up until a little while back, HashiCorp released version 12 or .12 of Terraform. And .12 can be considered kind of like a breaking change in some cases, where they've taken all their learnings and experience from 0 to version 11, all of the use cases that it's been used in all these different environments against all these different types of systems, and learned from some of the gaps and some of the challenges, especially at scale, people were hitting and encountering. And they took all that and they used it to kind of refactor and really double down on some of those areas within the Terraform language itself. And so they released version 12 that filled some of these gaps, changed some of the processes around this. So when you're working with Terraform, you have to be careful that if you've already written some templates or someone else has already written templates targeting version 11, if you go and they don't have a required version lock to a specific version greater than or equal to or less than and equal to version 11, for example, and you run this against version 12, because it will natively pick up whatever the latest one is that you download on your system, you can't go backwards. You can't go from 12 down to 11. You can go from 11 up to 12, but you can't go backwards. So that's why it's important and a best practice to have that required version there to ensure you're saying, okay, all of my code has been refactored and adjusted for the changes that have been made in the Terraform language for version 12 onward. So very important to keep that in mind. Then we have our back-end block. So in this example, of course, we see it's targeting Azure. And in here, we're actually targeting a storage account where we want to store that state file. By default, if we don't have a back-end block, Terraform will use what's called the local backend, basically wherever it's executing. So if you're running it on your laptop, your desktop, it's going to store that state file locally. And that's going to be a bit of a challenge when you work as a team. So it's a more beneficial, it's a best practice to use backends, especially working as a team, so that when everyone is executing their Terraform plans and applies, they're all referencing the same state file, and it locks it when one person is targeting it. Because if they're doing a deployment and someone else comes along and tries to do a deployment that might also change the same resources, you don't want to have a conflict. Also, it makes sure that you don't have sensitive information on your local system. We'll touch on this a little bit more when we hit state on the next slide, but state file contains some sensitive information. So keeping this in a separate location, like a storage account, or using Terraform Cloud, for example, you can have RBAC and controls around that. Okay, so let's kind of go in, since we've been talking a lot about state, let's go into that. I do see there's a couple of questions in the chat. So the one question is version control. Once the code is locked to version 11, does it maintain immutability characteristics, or is it preferable to not lock and make sure to get any updates on new versions like security updates? So if I understand the question correctly, with Terraform, you have to download the executable, right, to be able to, it's just an executable that you run locally to use Terraform. And you can go and download whatever version you specifically want to use, right? If there's breaking changes, or if there's like an alpha release of something that might disrupt what you're doing in production. So you're actually controlling that. And what that kind of does, when you put the lock in the template file itself, you're telling it, as it's doing its initialization, it's checking to make sure the version of Terraform that's running where you're executing your Terraform command matches that criteria. So it's not a matter of like missing like security updates or anything like that, but you're able, because you're controlling what version you download, you're ensuring that you don't, say, accidentally move up to version 12 and then have to go back and refactor everything on your development system, versus, say, someone else in your team is not using version 12, and now you're going to have a bit of a problem or a challenge. Now, I think there was another question here previously about syntax, that the syntax and structure of Terraform is similar, but the actual code is not reusable if you are deploying a VM in Azure and now you want to deploy in like AWS, GCP, or vSphere, so forth. Yes. Yeah. Thank you, Depesh, for clarifying that. We'll see that when we go through the code example as well. So state, this is what basically tracks your real world resources. It maps your real world resources to your configuration that you put in Terraform in your template. It keeps track of the metadata of what's been deployed. And like we said, it uses that local state if you don't specify somewhere else to store that. But it's important, it's a best practice to kind of store that in a different, a centrally accessible location. Now, when you run Terraform, it does a refresh to update the state file with the real infrastructure, and then compares your Terraform code, your template, against that to say, okay, what's different? What am I adding? What am I removing? What am I modifying? And you'll get that output. You'll see when we do this, you'll get that output from Terraform so that you understand what's going to happen. So please pay note to the really hard to read important thing in the bottom corner. I made it really hard to read because then it draws your attention to it. When you deploy things through Terraform, in the state file, it will contain things like usernames, passwords, keys, connection strings. So you have to ensure, if you're going to use a remote backend, which is recommended, you have proper security, RBAC governance control around that. That is telling you what is actually in the environment. So keep that in mind, specifically from a security and kind of like governance type of standpoint. Okay, just seeing if there's any other questions. Now, I'm going to mention this middle point here around state files and using separate state files. You can use them for separate like resource groups, applications, or certain services. So in that example that I mentioned before with like core networking, so all the templating done to deploy the core networking for this environment. When we deploy that, we have a state file that represents the real world of what we've deployed. That's fine. Networking team manages all that infrastructure as code specific to core networking. You know, virtual networks, subnets, NSGs, UDRs, all that good stuff. Now, what if the application team are also using Terraform to build and deploy the components and the resources required for their application? Well, when they're going to deploy it, they're going to have a separate state file that represents those resources. But what happens if that application that's being deployed needs a port open in an existing NSG? Now we're kind of crossing the boundaries between the application specific code and environment and the environment it's being deployed into, in this case, the networking construct. So if the application team were to call and reference an existing NSG that's managed by the networking team code, they could do that and update it and add a port open, for example, a rule, right? Provided they have permissions. But the next time the networking team reruns their templates, their state file does not match what the real world is. So now there's a conflict. Either things will not deploy correctly, there'll be errors, or certain things will be reversed and reverted back. Rules will be removed, NSGs will be removed or applied. And so you have to think about that from a life cycle perspective in relation to DevOps when these teams work together. So you have to, there's some really good videos that I link to in my curated list of resources that helps understand that progression between, I don't want to use the word siloed teams, but responsible areas, and then how that kind of meshes and merges when it comes to infrastructure as code that kind of overlaps in that aspect. Something we definitely need to keep in mind. We can use other backends, like we in our example, we had storage accounts, right? We can use Terraform Cloud, really awesome to use. Terraform Enterprise, Console, lots of different options available, not just one size fits all. So now let's talk about providers. This is that block that tells Terraform what environment or what cloud in this context am I targeting against. This is what's telling Terraform what APIs it needs to interact with to be able to work and deploy these resources. So in the example of the question about deploying a virtual machine or a storage account or anything across multiple clouds, you'll have a provider that's saying, okay, I'm targeting Azure or I'm targeting AWS, right? And so the code for the actual resource won't match one or the other, right? It's going to match one of them, but not both of them. We'll see that in the next couple of slides. Now notice here too, we have a version lock for the provider. This is because up until a while ago, it was version 1.x, and version 2 of the Azure Resource Provider for Terraform, which is jointly managed and contributed to by Microsoft and HashiCorp together. the 2.0 version brought another level of changes, again, similar to maybe calling it breaking changes in some cases, where we've simplified stuff, we've broken out certain resources to make it simpler to manage versus having everything combined into one, and so forth. So again, version locking the provider is important so that everyone in a team environment is targeting the right provider version when you're all executing the code. Definitely recommended. Optional, but recommended. Get into the habit of using version references for basically everything. Okay. Now let's talk about variables. Kind of very simple, right? We know what variables are. They allow us to parameterize our configuration. So like I said in the example, I'm deploying my core networking, and it's going to be in Canada Central in Azure in production. But then I can have a separate parameters file for Canada East in production, or for development in Canada Central, and so forth. So being able to write our templates to allow variables makes it obviously much more flexible and more consistent. And you can even have controls. You see in the variable, we have descriptions. Definitely get into the habit of putting that, because if it's you reading it maybe 6 months later, maybe if you didn't have a really good name for the variable, you won't know what it was for. Or think about the next person coming along the lines and looking at your code saying, okay, what's this used for? Again, being descriptive in the variable name, but also having a description is useful. Notice how we have a default reference as well. We can specify that so that if no value is provided for that variable when we're executing our Terraform plan and apply, that this default value, it will be assumed. So that's important too, for kind of like a default fallback, so to speak. Now we can provide these variables like we've talked about within the template itself. Obviously, we don't really want to hard code stuff as much as possible. We can have its own template file, but also have a TF vars file. This is kind of like the recommended way. This is the way I've done it for customers in that large global Azure environment, where we have a separate TF vars file for networking production Canada Central, networking production Canada East, and so forth. That way, you're targeting the specific template to deploy and then passing in the command line saying, this is the TF vars file I want to execute. And then again, consistency. It also gives us consistency in the infrastructure as code and in our repositories, because then we can see these are the actual values that we've used in deploying this to this environment. Note just briefly that they have an order of operations or precedence. If you pass something on the command line, that takes over or takes precedence over anything else. But in my actual personal experience, from a file, option 2 is usually the best with a mixture of some environment variables depending on the complexity of what you're targeting. Okay, let's talk about some dependencies. And do feel free to interrupt if there's questions. I don't see any yet, so that's either good or bad. It depends. Okay. So dependencies. In Terraform, we have implicit and explicit dependencies. Right. So when we have our template, we see in this example where one resource object is referencing something from another resource object. This is an implicit dependency. So the Terraform engine knows, okay, I need to create resource group first before I create this storage account because of that dependency. We can also have an explicit dependency and using the depends on argument within the code as well. If there isn't a natural inheritance this way, depending on what we're building, but we need to time things, or you need something to wait to be completed before we deploy something else, we can use that depends on argument. So a bonus around this, breaking news, right, is Terraform version 13, which is coming out in beta. It's been announced. The modules, which is a little bit more of an advanced topic, which we can do a follow-up session on, but for modules, we'll get this depends on support and this feature. That is really, really big, really important, and I'm very happy to hear that, because without that, it's a little bit challenging to call different modules of resources, but then make sure they don't stumble over top of each other if they're targeting the same resource. Very good to see. So there's a beta for that, I believe, coming out next month. And anyone from HashiCorp can on the call can definitely correct me if I speak wrong on that. Okay, so finally, one more thing that we want to kind of cover off is outputs. When we create resources, especially in large environments and interconnected dependent environments, we need to reference some elements across these. So outputs is how we tell Terraform, after you create this resource, I want this value back, so that then I can reference that output somewhere else, right? This is extracting that value, the value of that output from the state file once the resource is created. So a good example is, let's say we're deploying a virtual network and we have subnets, but then we want to also apply NSGs to those subnets. You need the subnet object ID effectively. You need that reference to make the association of the NSG. So you would have an output from the subnet for the ID object or object of the VNet, and then being able to pass that output value into a module for NSGs as the associating NSG to subnet association construct. Okay, so that's enough screen time for that. Let's actually see this live. So if you can confirm that you can see my screen still, Arlen?
I can see it. It looks great.
Awesome. Okay, so I have a blank Terraform file here. I just have these commented out just to remind me the order of operations that I want to write these out for you live. So the first thing is we need that Terraform construct, right? So we need to say what version. So required version equals, and then greater than or equal to 0.12.0. The next thing is the provider. So in this case, we're going to target Azure. So we're going to say Azure RM, Resource Manager. We can even actually choose the backend to see that backend block, right, that it puts in there. If we wanted to configure that for, actually that's the data, my bad, sorry, TF Azure RM, there it is. What subscription we want to target, the client ID secret, so the service principal that we want to use, the tenant and so forth. I'm going to comment that out specifically. But because we're going to target and say version equals and version 0 or greater than, greater than and equal to 0 or 2.0.0. Now, another element that's new with the version 2 of the provider is a features block inside here. You don't have to have anything inside this features block, but what it allows you to do is kind of test some preview features if you want to flag some of those in there if they're exposed. But you still need to have this features block here to be able to execute against that. There's a question for the provider. Can you reference the client secret with a key vault so the code does not have any sensitive info inside? Yes, good question. Yeah, absolutely. So Terraform can you can leverage like Azure Key Vault. You can use a HashiCorp Vault. Oh, if someone could please mute themselves. I'll let you take care of that, Arlen. But yeah, so now I was muted. You can reference a secret store like Azure Key Vault or HashiCorp Vault. Absolutely, you can reference that. for sure. Definitely don't want to have secrets inside of your code if not possible. But from a development or from like a testing perspective, you could put that in there. The next piece of code, let me just drop this down. The next piece of code that we want to do is the variable. So TF variable, and we'll include a default. Oh, again, we're going to call it whatever we're going to call it, and we're going to say West US, because it's going to be location, and then we are also going to say this is type equals string. And I have my little cheat sheet in case I mix up some of my code. The next thing is we're going to create a resource group. Yep, and Depeche gave an answer as well, that you can set them as environment variables. You can also, like with environment variables in like a DevOps pipeline as well, for example, so that the developers don't even need to know what they are. They can just reference it and be able to deploy without having to set any of that up for themselves. So, sorry, the next one is resource group. So we go TF Azure RM, because that's the provider we're targeting it, and we're going to go storage account. So here's our storage account. We have a name. Now it has to be all lowercase and it has to be unique in the world, so to speak. So we're going to call this tag May 2020 storage account. Now, sorry, my bad. We're supposed to do resource group first. Azure resource group. There we go. My bad. There we go. And let's call this tag 2020. And for location, we're going to change this instead of hard coding, say variable.location. So now we are saying we are going to use this value. So we can either pass this in on the command line or it's going to assume the default. For the resource itself, for the storage account that I jumped ahead on a little bit, instead of, we could actually put in the name of the resource group. We can hard code it to copy and paste, but obviously we want to be as flexible as possible. So in this case, we're actually going to say we want to reference the Azure Resource Group resource type dot the name. So this correlates to the name that we're calling it in the code, dot my resource dot name. That way, if we just change this resource group at here, it will be inherited any changes down to this. There's a question, can I put the variable in a different file? Yes, you can. Absolutely. You can put variables in different files, for sure. Next is location. So in here, we could actually do the same thing and put var.location right here. It'll accomplish the same thing. However, we can very similarly use the reference to the to the resource group and put .location as well. And we'll just leave the rest as is right here. And then the last thing is the outputs. So TF output. So it's not just an Azure thing, it's my output. And we're going to say, what is the value that we want? So we want to actually we want to get something from the storage account. So maybe it's the connection string, right? Because we need to be able to extrapolate the connection string as part of some other piece of code. Because it's really long, so I'm going to just grab the access key or the connection string piece here from my sample. And that's what I want Terraform to produce out of this for me. So now we have our template here with all our bits and pieces. So now we're going to execute this. So I'm going to actually bring this up a little bit higher so we can see it a bit better. First thing we need to do is Terraform init. So notice a couple things happening here. First of all, it's checking for provider plugins. Let me scroll back up. It's checking for the provider plugins. So it's seeing that my provider is set to Azure. So it needs to go and download the provider from HashiCorp, and the latest version that's 2.0 or newer is 2.11. And I see I have an error here somewhere on line 9. Maybe it's versions. Let me just double check. Required version. Maybe I spelt it wrong. Yes, I did. I forgot the S. Thank you. All right, let's try that one more time. There. So notice now also it's initializing the backend. I haven't provided one, so it's going to use the local store of where my code is sitting in my directory here. And now the next thing, I'm going to clear this out. Terraform plan. Tell me what's going to happen. Oh, it's features. Double check. Yeah. Always forgetting the S. Sorry, guys. And so notice it's refreshing the state in memory to calculate what the difference is going to be when it executes this. So it give it a minute. It's going to go, since we haven't deployed anything, it's going to say, oh, you want to do everything. Everything doesn't exist. So we see here plus green, create, and it says we're going to create a resource group. This is what you're passing in. The ID obviously is going to be known after it's been created. And then we're going to create this storage account as well. Notice if we look here, location, it's showing the value of West US from our reference to the resource group's location property, which is itself referencing the variable that we've created. Then also notice down here, it should have the resource group name. Here's the resource group. Again, the reference from inside the storage account resource object to the resource group specific. All this is green plus, so we're saying this is all going to be created. It says 2 to add, no to change, none to destroy. So now we're going to go ahead and apply this. Terraform apply. Now here is where it's going to produce basically the same output from the Terraform plan. It's going to get ready to execute it, and we're going to be prompted to confirm that we want to do this. A simple yes will do. So when we do that, now it knows, now I can go and trigger this against the APIs in Azure and deploy this environment. So give that a moment. You'll see the output here. It's creating the resource group first. Once the resource group is created, it says complete. Now it's creating the storage account, right? And that's going to take a second to create. You know, it keeps you up to date as to the process of what's going on until it's completed. Once it's completed, it'll again spit everything out and show you this has been done. You'll also see from the output here, see 2 added, here's the outputs. So if we look at our code, this is called my output. That's what's labeled here. So if I needed to reference this connection string in another module, I would call, you know, the output of my output to get this specific value here. I see there's a question in the chat. Does Terraform allow for DevSecOps and allow to put in the sequence of build some security tools like OWASP checks and so forth? So Terraform itself, you wouldn't put it in the Terraform code itself, because that's the templating language, but rather you would put it in your DevOps CI/CD pipeline process to evaluate that code from a security standpoint before you even allow it to be executed and deployed. There's other things you can kind of add-ons you can kind of piece into that. HashiCorp has a tool called Sentinel. Nope. Yes, it is. I think. Sorry, my bad. I think it's Sentinel as well. I'm getting mixed up with the Azure stuff, where it checks against policies that you put in place before something is deployed to ensure that it aligns to certain requirements that you specify. So that's more in the workflow deployment process versus the template language itself. So if we go over to our Azure environment, we see here's our resource group, here's our storage account, and everything is happy. It's GRS, so the primary location is East, but then has GRS for East US. Now let's go back to our code and make a slight modification. And I'm going to cheat and grab it out of my example code here and grab the tags. We're going to go and add tags to the storage account. And we're going to not comment that. Oops. So we're going to add an environment tag, and we're going to call it staging. So if I clear this out, go Terraform plan again, it's going to go and check and see, okay, what does it know about my storage account as it lives in the real world today, and compare that to my plan and say, what is the difference? So we see it's refreshing the state of the objects, and in a moment it'll come back and it will show that we are modifying this existing resource. So see, one to change. So if we scroll up a little bit here, it's a little hard to see. It is yellow when you have a dark theme. This is a yellow squiggly update in place, and we're updating the storage account. And down here, we are updating tags and adding a specific tag. So then if we go Terraform apply, we can say, we can let that go. It's going to ask, it's going to prompt for that. So notice Terraform plan and Terraform apply both check the state. Now it's like, this is what you're going to change. Are you sure you want to do this? Yes, we do. And while that executes, now it says modifying. Now, while this is going for a moment, because this is a yellow squiggly, say it's in place, an in place update. Sometimes, depending on what you're changing to a resource, a certain property, a certain configuration, it'll actually show you it has to destroy the existing resource and create a new one. That's subjective to what type of change you're making. Now, there's more advanced elements around Terraform where you can control the execution and say, do not destroy the existing resource until this new one is created first, so that you ensure you don't bring down, say, your service or your application. Again, we get the same output, but if we go back and we refresh, we should have our tag environment staging. Okay, so let's do one last thing. Terraform destroy to clean up. So again, it's going to kind of check, what do I have? What are you going to destroy? It's going to warn you. Everything's going to be red with a minus red. You are going to destroy these resources. Are you sure you want to do that? See, all this is red to remind you this is being removed, will be destroyed in red. So you don't accidentally say, oh yeah, sure. And then we hit yes, and then it'll go off and do that. So we don't have to watch that specifically. We can go back to our deck and go, and let me just flip this back properly. There we go. Okay, so now that we've looked at Terraform, we see kind of how the templating language works, how things kind of interrelate, and from a templating perspective and infrastructure as code. Now let's compare it to what we know about ARM, right? I call it peanut butter jelly time because they go together, sort of, right? Depending on where you're coming from, but it is a better together story, ultimately speaking. So when we're comparing the two, right? I'm not going to read all of this, but I'm going to highlight a few things in this slide and the next one with the comparison. When you're, obviously both of them are infrastructure as code. One uses JSON, one uses HCL. Execution plans. ARM has this new what if feature in preview, which is similar to like the Terraform plan to kind of say, if I'm going to deploy this code, what's going to happen, right? For things like multi-cloud, well, obviously ARM is an Azure specific construct, so you can't use ARM to deploy against AWS, for example. There's a question in the chat, doesn't Terraform support JSON as well? Yes, it does. You can actually write it in JSON as well, but HCL is cleaner to read and see, as we'll see. Good question, though. Obviously, so Terraform does support multi-cloud. That's a lot of the reason why a lot of organizations like to use it. Then it's one language construct, one element to learn, the HCL language and syntax, and be able to write the templates for Azure, for AWS, or for wherever. Right? For configuration, ARM has this new preview for inline deployment scripts where you can execute PowerShell scripts. Terraform has provisioners and other providers. So a good example here is Terraform actually has a provider for Chef. So you can write your infrastructure as code template to deploy your systems, your virtual machines, and so forth, and then also use Terraform to initiate and call Chef to trigger a configuration to be applied to those deployed systems. So you're not using Terraform to make the configuration as code, but you're triggering the configuration as code as part of that process. Couple other things to call out based on experience, Azure preview features. So obviously when Microsoft, when we release a preview feature or service, it's obviously natively there in our ARM and API constructs as is required. With Terraform, people will notice that there's a bit of a gap before a provider is available in Terraform. One workaround for that is to embed an ARM template inside your Terraform template. Not a great thing to do when it comes to certain things, but it is a way to work around that. However, I'm able and I'm happy to say and kind of share that both HashiCorp and Microsoft have teams that work together very closely on the Azure Resource Provider, like we were talking about earlier. So we're working very hard to expedite when new features are released from an Azure perspective, how quickly we can get those into brand new providers for Terraform or update existing providers for Terraform. Ideally, we want to drive that down to a really, really tight time frame, but we're not quite there yet. But that's where we're driving towards, because we want to treat Terraform as like a first-class citizen. Many organizations use it, so we want to ensure whether you're using ARM or Terraform, you have a consistent experience in operating against Azure. A note on the state, with ARM, there is no state to manage. With Terraform, there is. Not a pro or con, but like we showed, like we talked about, state controls or has the real world environment, right? This is literally what's live in the world today. So if that gets corrupted, then that can be a bit of a challenge, a little bit of an issue to work with, to remediate against. Not necessarily a negative, but it's something you need to be aware of and why you want to make sure you use remote backends, you have proper RBAC and control and protection around where that state file is stored. Because if something were to happen to it, you need to be, it is what your environment is. So just keep that in mind. Obviously, lots of support for DevOps and parallel deployments and so forth. Continuing on this, a couple of things here to keep in mind. When you're deploying resources through infrastructure as code, really, if you're going infrastructure as code route, stay infrastructure as code. Don't go into the portal and make other changes outside of that, because that's going to cause challenges from this perspective, because now your template, whether you're using ARM or Terraform, does not align to what's real world, and that's going to cause some issues to work around. ARM, even though you can go and it won't mess up the ARM template itself that you're deploying with, Terraform again relies on that state file to say what's real world, what do I need to change, and if that doesn't match real world, then there's going to be conflicts in it and challenges. What else? Maybe sub-templates and modules. So I've worked with ARM and Terraform for a long time. Yes, you can have like sub-templates and link templates in ARM. It can be a little bit of a challenge to work with. Modules I find a lot easier to work with from a Terraform perspective. It's just groupings of code or code files in a separate directory. That can be one module, and you can just call into that and pass parameters and values into that and get those outputs back out of it. Oh, there's a question. What do you do if Microsoft releases an Azure service that is not part of Terraform yet? So yeah, we mentioned that on the previous slide, I believe, where if we release something brand new, like a whole brand new service, that's not available as a Terraform provider just yet until our teams work collectively together to create and release that, hence the update to the ARM Terraform provider. If you want to still use Terraform and target a resource that's not yet available as a native Terraform provider, then you can take an ARM template and embed that inside your Terraform template, effectively wrapping your ARM template in Terraform and use that to deploy it. And Depeche says, or you can run Azure CLI using the local exec provisioner. Thank you, Depeche. Appreciate that. Okay, so let's kind of look at this side by side real quick, just to kind of help bring it all home a little bit. We looked at Terraform, we wrote some of the code to see. We see Terraform is on the right, ARM is on the left. So we see ARM is kind of XML-ish based in its structure and its context, and Terraform, you see it is a lot cleaner, easier to read, right? This example is using version 11 because you see the $ and the quotes, which aren't needed in version 12 onward. But we can see kind of the side-by-side comparison to get an idea of how they're similar, but then how they're a little bit different, right? So there's a question about embedding an ARM template in Terraform. If I can show how this is done, I'll see if I have time to show that. I don't have an example prepared, but we can see what we can accommodate for that, or find an example of that for you. So let's talk about best practices. So you do it right the first time, right? No one wants to do it and then do it again, right? Or have to walk back and like redo something. We want to make sure we start on the right foot, with the right practices going forward. Thank you for the link, Dave. Appreciate that. So here's just briefly a couple best practices to keep in mind when you're starting off in Terraform. Use remote backends, even if you're like a one developer shop, one person shop, and you're just doing it locally. Get into the habit of using remote backends. That way, it's much easier to expand the team or transfer to another team that's going to take over that code. Say if you're consulting for them, get into that habit on how do I configure backends. Whether that's in storage accounts. I definitely recommend taking a look at Terraform Cloud. There's a free version of that I've used, really slick, really easy to use as a remote backend. So let's say if I'm developing on my laptop somewhere, I'm pushing that state to the Terraform Cloud, and then come home on my desktop, I can reference that exact same state file and not miss a beat and continue on my development. Next is we want to get into the habit of using version references for Terraform itself, like we talked about, for providers as well, like we talked about as well, but also for modules. We haven't covered modules because that's more of maybe an intermediate advanced topic that we can do a follow-up session on. But when you're putting in versions, it allows you to experiment and try something and add something or remove something in a development and iterative fashion, but then being able to pin to a specific version so that you're breaking changes, or as you're working through some other elements, you're not breaking something that's dependent on in production. Definitely use your implicit dependencies. That's a really good feature with Terraform, being able to kind of know where those dependencies are based on what you're referencing. Modules, very, very helpful. There's some stuff provided by Microsoft, provided by HashiCorp, provided by lots of other providers that do a lot of the common activities that you can just call directly and get the output from, or you can create your own custom ones. I've done a lot of custom ones for that global networking example I've been referencing to, and that's something we can maybe follow up with another session if we want to dive into that. Use ARM templates only if you don't have any other choice. That's in the context of, similar to the question that was asked, if there's a new Azure service in this case, and there's no provider released just yet for that, then you can at least deploy it through Terraform by embedding the ARM template inside of it. But ideally look to see if there is a native provider, because then that ties everything better together. So now let's just wrap up for the last few slides here. We want to provide some resources for learning stuff, right? Where do you start? How do you begin? Because the internet is full of everything. So here's a few key resources that I found useful. That first one is from the individual at an organization. I found his topic or his article really insightful on why they chose to use Terraform and not like Chef or Puppet or Ansible or so forth for their deployments. And that's where the construct of Terraform is designed as infrastructure as code, right? That is its design-driven purpose. Use other tools that are design-driven for configuration as code, because that's where they excel. So some of these links that we have here are available at that QR code if you want to scan that, or if you want to go to the aka.ms short link. That is an O, not a 0 for ON. There's some best practice labs, so you can get some hands-on experience with understanding the best practices of using Terraform and seeing those constructs broken down. Things like our aka.ms/tf Terraform Hub is where you can go to the Azure specific documentation on using Terraform. There's lots of information there. As well as in the bottom here, the last link is my own personal curated list of learning resources. So as I was just starting to learn Terraform, I read, those that know me, I read a lot of books. I read a lot of articles. I watched a lot of videos, did a lot of different hands-on stuff to help me learn all of these constructs to learn Terraform, because I was coming from the Azure world knowing ARM. So I needed to understand how things related. This is my personal curated list that I found the resources most effective in understanding not only the Terraform language, but things like working and operating as a team with the state file and things like that. So definitely hit that up if you want. I'm just checking if there's any other questions. So there is a question of, can we export configuration for existing infra in the cloud? So something that already exists. So I'm going to say sorta, but not fully. So what I mean by that is, let's say you already have an environment deployed in Azure or in the cloud, and you want to bring that under Terraform management and control. You have to write in Terraform the resource blocks that correlate to whatever resource objects those are, and you can use a Terraform import command to now basically bring those resources under the management so that Terraform knows about it in the state file and then be able to operate that. It's not that you can target, say, a resource group or a bunch of resources in Azure and say, go generate my Terraform template file for me automatically. That's not the case today. I can't comment on that specifically, but yeah, so there's a little bit of work that's a little bit more of an advanced topic that we can maybe follow up on. Let's see. Will copies of the slides be available to us plus the recording? Yep, absolutely. It will be available on the, I believe on the meetup page is where that'll be posted for sure. Also, I want to call out bottom blue box. if you're starting to develop Terraform templates and code, you're going to want these two extensions to help you in building that faster and in a more streamlined way. The first one is the Azure Terraform Visual Studio Code extension by Microsoft, and the other one is another Terraform extension that was originally produced by Mikhail, but now, thankfully, happily, HashiCorp has now taken ownership of that and now will work to keep that up to date, to use its new language processing engine, and we'll see even more goodness coming out of that. So definitely two extensions that you're going to want to use when you start to author your templates. Okay, two more slides. This one, a lot of people have been asking and reaching out about certification because HashiCorp has released publicly now their Terraform and their Vault Associate exams and certifications. So myself, along with an Azure MVP, Ned Bellavance, we've authored a Terraform Certified Associate Prep Guide. We were authoring this before we knew HashiCorp was releasing their own study guides. So we've released this. A lot of people have had a positive feedback on this in their preparation for the exam itself. A lot of people have said it's been really helpful. So go definitely take a look, check that out if that's useful for you. Also, HashiCorp has thankfully officially also produced study guides, exam reviews, and sample questions to help you in preparation for that Terraform Associate certification. So lots of resources available for you if once you get rolling in Terraform, if this is the direction you want to go and you want to have a cool badge to say, I'm certified, I know this much about Terraform, definitely take a look at these resources. And with that, this is my last slide. This is who I am. This is what I do, among many, many other things. Feel free to connect with me on LinkedIn or follow me on Twitter, reach out to me on email, so forth. Take a look at my blog. I do write on my real world experience with Terraform and Azure and many different things that I operate in. I do work for Microsoft now as an Azure Apps and Infra Cloud Solution Architect, and do many other things around governance and BCDR, and of course, infrastructure as code with ARM and Terraform. So with that, I will leave it here. If anyone wants to come off mute or if there's any questions that have been missed.
Thank you so much, Aidan. That was fantastic. So Aidan.
Yes.
Are you still available? We have about 15 minutes left in this time window. Do you have any more time for any additional questions or maybe an example or anything else you'd like to show? I think there's a few questions. There might be one was about the availability of the slides, so I could answer that. So this slide deck will be made available on this meetup page for the Toronto Azure Group later this week, along with the recording of the session. So feel free to grab both of those as well as share them out to your friends and colleagues who want to learn Terraform. And I think that's the extent of the questions that were still left here.
Yeah, I'm just taking a look in the chat. So maybe just for everyone, obviously this was more kind of Azure, or sorry, Terraform 101, kind of some basics, foundational stuff to get you started. If there is interest in more intermediate or advanced level topics like the modules, the import, and those type of elements, comment maybe on the meetup page so that we can gauge the community's interest in that, and then we can work to develop that content for you as well.
There was a question that I found, or actually more of a statement that was really interesting from Depeche, which says, build modules as separate repos rather than in subdirectories. This helps you with scaling and versioning. Is that something you could comment on at all, Aidan, with your experience on that?
Yeah, so good. Yeah, it is a good comment from Depeche for sure. The challenge with that, it is a good way of looking at it, but then you have to make sure you have a consistent framework or structure that you're going to follow for your repos as well. So, if you have one repo with all the networking bits and pieces, or how you're going to separate that out and like ownership and who can call what, You just need to make sure you think about the management of the repos as well. But for sure, because then, like we talked about with the versioning, you can have, here's your production version of this module to, say, update an NSG, but then you can also develop like an alpha beta version of that module that you're adding new functionality, or there's a new feature in Azure that you're going to apply in there, or something to that effect. Yeah. Let's just see if there's any other questions that I missed. If there are any questions, definitely post them in here. There's a question about, can we use Terraform to deploy the latest Windows Virtual Desktop deployment in Azure? That's a really good question. From what I have seen in the public so far, I don't believe there is a native Terraform provider for WVD yet. So what I've seen people do is do that ARM template embedded inside a Terraform template currently.
So Aidan, there's not many questions left right now. Actually, I think that was the extent of the questions we had so far.
Okay.
Was there anything else you'd like to show or demo in the remaining about 10 minutes we have left, or should we wrap it up today?
I don't have like really complex code samples that I can share right now, like up in front of me. So I'm good. But like I said, for anyone else that has questions,
Hello.
like, oh, yep, go ahead.
Right, sorry. I know you mentioned this earlier. You said that, this is Ali, by the way. You said that Terraform is not a portable language, sort of speak, between the different clouds. That means, that leaves me, if I'm using, for example, 2 clouds and I want to use Terraform, I have to maintain 2 versions, plus whatever Terraform is not able to do, I have to use the native capabilities of whatever, say, for example, I have Azure and AWS.
Mm-hmm.
That seems a lot to maintain in terms of code and code versioning and maintaining that code manageability life cycle.
Yep.
So why? I guess what I want to ask, why do I want to add that headache to myself as an enterprise?
Yeah, so good question. Yeah, and that's kind of part of the key for everyone to understand. It's not that, like, Terraform itself is multi-cloud in the sense that the language that you learned, the HCL construct here, can be used against Azure or AWS and so forth. But if you recall, when we talked about the provider, so we see here, we're saying we're going to use the Azure provider or the AWS provider. Now, in the example for our storage account resource here, right? If we have the Azure Resource Provider, storage account construct, these are the properties that Azure understands and the values that Azure accepts and understands. If we were to do like AWS, now I don't have any experience with AWS, so I'm just gonna, nope, that wasn't it. So I don't know the correct, is it? That's the backend. So sorry. So, but my point is that with any other cloud provider, and it just takes any one of these, I guess. So notice how it's like, okay, this is AWS and it's OpsWorks application, blah. So you could have multiple providers in the same template, but the code block that you're developing for this will have properties that are specific to that provider. So it's not like you can say resource, generic storage account, name, resource group, location, because the construct of, say, resource group is an Azure specific terminology, right? Or property, and whatever AWS calls it is something different. There's no translation between the two.
I got you. I misunderstood your first comment when you answered this. That's why I had this. But thanks for. So now, okay, now if I understood you correctly, that means Terraform is offering me a unified framework for infrastructure as code to deploy in the cloud. But I might be able to maybe come up with parameterization for these things so that when I am deploying, I can use the same framework. But if I am deploy, like I will have a variable, oh, you are deploying in AWS, then this is the bunch of things that you have to use versus this is for Azure, versus this is for GCP or something like this. So I can see the advantage now on what you are talking about, at least to me. I don't know for the rest of the audience, but thanks.
Yeah, so it's not like, just to maybe correct you a little bit, it's not like you can have a generic resource either and say, I'm going to make this resource object reference, the resource type, like a parameter, and say, oh, if it's Azure, then this is what it needs to pop into here versus AWS. Because again, the properties underneath here, in Azure, we call it, tags. It might be the same in AWS for that specific construct, but resource group might be, I don't know what it's called in AWS because I'm sorry, I don't know AWS.
Okay, let me then ask you this, because I don't know Terraform that much, but I do have background in development and coding in general. Let me ask you this. Can I put there an if statement that reads a parameter, and according to this, it will bring another file that will contain that block? So if it's Azure, call file Azure. If it is AWS, then call file AWS, and it will have these things. So sort of conditional include of a file.
Right. Yeah, that's kind of maybe where, yeah, there are some logical constructs in there, like loops and ifs and that type of thing. So,
Okay.
However, as far as like calling a file, it would be more, you would be calling like a code block. So in here, for example, you would have like count equals, and then the like if, for example, this isn't gonna legitimately work, but like, so like if property dot cloud is equal to Azure, right? Then the count is going to be 1, for example. Because then if that property is not equal to Azure, then you're not deploying this Azure resource. But that kind of, I would advise against mixing and mashing different cloud templates together. You would want to have that separate, right? You wouldn't, I get from like, oh, you only want one template to call and then there's some logic around there, but it gets a lot more cumbersome to manage the code lifecycle of that template if you're calling multiple environments like that.
So your advice is that to develop a Terraform, sort of speak, a Terraform code for each cloud deployment I have.
Yes, correct. Yep. So
Okay.
and that's kind of where like people have to realize that, okay, again, there's no generic Terraform storage account and it will magically know the right properties and values that Azure accepts versus AWS, and then figures that out magically by itself. That's why when you create the resource blocks, you're saying I'm making an Azure storage account. I'm making an AWS S3 bucket, right? And these are the properties that it is looking for, that the API that Terraform calls is looking for, and the values it allows to be accepted by the API. And so I would definitely separate the two for sure. So
Thanks,
Bernie,
Aidan.
yeah, no problem. I see there's a question from Bernie that says, how does a Terraform template know what context is to be used in Azure? Can you maybe elaborate a little bit on that for me, Bernie?
Yeah, so let's say I've got a couple different tenants or a couple different subscriptions within the tenant. How does the, like in the demo that you provided, I didn't see anything that was showing, you know. Okay.
Right there.
Okay, cool.
In the provider block, so you specify subscription. You can pass it like as a parameter, right, or a variable there. Tenant, right, as well. Also, you can have multiple providers, and I don't have an example of this readily, so this what I'm going to do now isn't going to be legit, but you can have something. It's something along the lines of like an alias, I think it's called. If I can spell. Anyways, alias, whatever. And then it's like prod, for example. And then this one would be non-prod. And then in your resource, you can actually say, okay, this is going to be a storage account in, say, .prod or within the code block. I forget exactly where it is off the top of my head. But that way you could even have a differentiation for subscriptions and tenants within the same code block, prod versus non-prod. But
so
would you really do that? Sorry, go ahead.
Yeah, no, I was gonna say, so when you ran the demo though, all of that stuff is commented out. Did you already have that context set through your through the Visual Studio Code?
Yeah, so I already logged into my.
Okay.
Yeah, for the purpose of the demonstration. Yeah.
Makes sense.
Right.
Okay.
Like way up here, I have all my accounts somewhere listed up here. So yeah.
Cool. Okay. Thanks.
Yeah. Would you really do that? You could. I have seen it done. It kind of depends on the scenario, because really, if you're going to try to separate prod from non-prod, maybe really at the subscription level probably is where the delineation would be. Else, all the code should be the same, because you want developers to deploy the same structure of infrastructure in dev and all the same configurations as it's going to be in prod, so you don't get the it works on my machine versus it doesn't work in prod, right? Thank you, Depeche. He's got I typed it wrong, so he's got it's alias equals alias name. I just can't spell today. Alias equals, and then say production or prod or whatever. Oops. Appreciate the help, Depeche. There's also we can call modules and code blocks to manage resources. Yeah. So when we get into like the module stuff, again, that's what I kind of feel is maybe intermediate advanced stuff, where I can show some of the larger scale code that I've developed for that global networking deployment that heavily uses things like TF-vars files and modules calling other modules and outputs and so forth, and separating files between just the actual code that's being deployed and have a separate file for like outputs, so it's all kind of structured and organized. So if that's something of interest, we can definitely work towards doing another session on that. Just comment on the meetup page so that we can judge the interest and fill that gap. So there's a question. If I will develop for each cloud separately, I will be adding new layer of code lifecycle management. I would use the native code for each cloud and manage them this way. Yeah, so good point, and that's kind of the point of it all is when or why would I use Terraform? A lot of organizations, even though you can use the cloud native templating language, so ARM in Azure, Cloud Foundation in AWS, and obviously you have immediate access to like preview APIs and all that good stuff. A lot of organizations still like to leverage Terraform because it's one language syntax construct to learn. Yeah, you gotta rewrite some of your code to target like Azure versus AWS, and again the properties that it needs to reference specifically, right? But it's still this language. Once you get the hang of Terraform in general, then you can just easily, dare I say, easily shift from say Azure to AWS from a code development standpoint. There's a question of, will Microsoft acquire HashiCorp? I am not in a position to answer that. I'm not Satya, so I can't say whether that will happen. I don't think so, right? But I've asked that question myself in the past, so, but the answer's always been no.
So thank you, Aidan. We're at 7 o'clock now, and it's time to start wrapping up here. I just had one question for you on the VS Code extension that you're using for your code completion. Which one is that you're using to?
Yes. So there's a few in here. So there's this one is like the syntax highlighting, right? Which helps for readability, which we provide the link to. And then there's another one. There's a snippet one. There's a couple of different ones that do snippets. I'm trying to actually let me find. There's another one that I use for snippets. I think it's this one, Advanced Terraform Snippets Generator. Yeah, that's the one. So TF dash, and then it generates the block. Now, the only challenge with this one, though it's really great to kind of get started, notice the notification here that this individual, Richard, needs help to maintain it. So it won't necessarily be completely up to date or have all the latest properties for the various environments and so forth. So it gives you a good starting point, but it won't be, say, 100% complete. That's why I'm excited about Terraform taking over some of the other official extensions or becoming official extensions, and hopefully kind of building some of that into a HashiCorp official extension feature set.
That's great, Aidan. Thank you so much. So it's time to wrap up this meetup, and I would like to thank you very much for this great presentation, and to remind everyone, this presentation, the slide deck you just saw, as well as the recording of this video, will be made available later this week on the meetup page. And I want to thank everyone for coming out and for your questions and your participation. It always makes for a great community and a chance to learn together. Thank you all very much, and I'm just going to stop the recording and wish everyone a great afternoon, evening, night, morning, depending where you are in the world, and take care and stay safe.
I do see one other last quick question in the chat there about with Microsoft pushing VS Code, should one still lead towards Terraform? Yes, for sure, because Terraform is not an IDE, code development interface, right? Environment. Like you use Visual Studio Code to create your Terraform templates. Terraform doesn't, like, it's not one or the other. They work together. Whether you're using Visual Studio Code, Visual Studio, Sublime, whatever, it doesn't matter what environment you're using to create your coded templates, right? VS Code is great because it has the extensions and the syntax and stuff. It's not, do I use VS Code but don't use Terraform? That's not a question.
Thank you very much, Aidan, and I'm going to stop the recording and wish everyone a great rest of your day, wherever you are in the world. Stay safe.